Flight School from Above is a production of the Fairfax Network, Fairfax County Public Schools, in conjunction with the Smithsonian's National Air and Space Museum Stephen F. Udvar-Hazy Center, with a generous grant from FCA Nova, the Armed Forces Communication and Electronics Association, Northern Virginia chapter. From the first moment we flew above the Earth, we've been looking down. Making observations range from the trivial,
"Look, I can see my house,"
to the significant.
"There's a hurricane heading our way."
During Flight School from Above, we'll float in a hot air balloon.
When you think about the impact of flying on these first people who did it, the first people who went up in balloons, it must have been really incredible. And you can see that when you read what they wrote. What you have to remember is that they were the very first people to see the world from an entirely new perspective, from above. To watch human beings recede in the distance, to watch houses get small, to move across rivers and mountains and the old natural barriers. This was really something entirely new, and it did have a huge impact on these folks.
We'll see what the Wright brothers saw.
You've seen pictures of the Wright brothers in the air, and you've maybe even seen movies of the Wright brothers in the air. What did they see? What was it like to actually be sitting in this seat, or sitting in this seat, and up in the air? What did you see? What did it feel like? The Wright brothers in 1908 and 1909, because they had this wonderful machine, were able for the first time to take passengers up and let them see what it was like to fly. But also, they took motion picture camera up. They took a cameraman in 1909 when Wilbur was flying outside Rome, Italy, went up and made the very first film ever shot from an airplane. And if you come around and sit with me, you'll see what that looked like.
We'll hover in a helicopter.
Early on, the helicopter was advertised as the modern magic carpet. And it really is that, because it gives you a perspective that you're just not going to have from anything else.
You truly, literally have a bird's eye view of the world. And things look, when you see things that appear complicated on the ground, things appear simpler up there. The puzzle piece, the edges of the puzzle pieces merge together, and you truly see the Earth's beauty, I think. You see how cities are laid out. You see how close things are that you really thought were much further away. It might take 40 minutes to drive to Rockville from here. It's only a 10-minute flight for me, and when I take off from here, I can see Rockville on a clear day. So it makes the world appear much smaller, and things blend in. The problems of the world seem to disappear from a bird's eye view, and the further up you go, the more things blend and the more beauty becomes apparent, I think.
We'll soar to the ceiling of our atmosphere.
Now, once we get up to cruise altitude, we're about 14 miles up. So right away, if you think of looking at something from 14 miles away, you're looking at all the big objects. You're not seeing the fine detail of, let's say, boats on a lake. You're just seeing the lake. But the view from up there is unbelievable because, first of all, we're in the stratosphere versus the troposphere where we're used to living down here. There is no water vapor up in the stratosphere. There's no haze. There's next to zero pollutants up there, and so it's perfectly clear sky. And so as we look out from 14 miles up, over 70,000 feet in altitude, we can see over 100 miles away, 200 miles away in many cases, if it's a large enough landmark. I've flown over Lake Tahoe in California and been able to see the Golden Gate Park in San Francisco, almost 200 miles away.
And we'll observe the planet from space.
Nowadays, we have dozens of platforms in orbit returning images all the time. If you were to ride in those spacecraft and take a picture, or just with your eyes, it's a very beautiful sight. Astronauts often talk about how they spend all of their free time staring out the window at the Earth's land surface. So the images that we have on display in this gallery and other images that come from different kinds of satellites are useful to look at for two different reasons. First of all, we can use them for scientific and technical purposes. We can measure changes on the Earth's land surface. But sometimes it's nice to look at these images just because they're pretty to look at.
As we fly higher, our perspective and observations change, thus changing the way we see the planet and ourselves. We'll meet the people and the vehicles that help us study the Earth from above and transform flights of fancy into flights of fruition. You can learn a lot from above.
Welcome to the Air and Space Museum's Stephen F. Udvar-Hazy Center, located in Chantilly, Virginia. Today we bring you the final class of flight school. Throughout the series, you've explored the history, science, and technology of aviation while meeting the men and women who inspire us to fly, to go higher, faster, farther, and to blast off into space. By now, you know all about things like thrust, lift, pitch, and yaw. And today, we put it all to work to help us gain new perspectives on the Earth and its inhabitants from above. Speaking of above, Mark Lindesay is high above us on the other side of the building. Hey, Mark, you are way up there.
Hello, Kate. How are you doing down there?
Go, really small.
Well, I'm standing on the skywalk high above the main hangar, and the view, it's spectacular. Not only are there aircrafts right here at eye level, but I can see so much more than if I was downstairs with Kate. And that's the idea of this show. What can we see and learn by being above it all? And what if we went even higher than I am here? Here's a quick example. Let's start above the U.S. Capitol building in Washington, D.C. I see on the right, they're working on the new visitor center. Cool. A hot air balloon. Whoa, watch out for that helicopter. Now to the edge of the atmosphere. Things look a lot different up here. That's a Lockheed U-2. And for the big picture, it's into space. Hey, that's a GOES weather satellite. Ugh. Talk about a runaway elevator. And we're back where we started. As you can see, the higher we go, the more our perspective changes, and the more we can learn. And speaking of learning, you're going to have to do a lot more than just enjoy the view today. I'll be back with questions from our flight school quiz. There are a couple of them, so have fun today, but be sure to pay attention. Now back down to you, Kate.
A quiz? Oh, that's all right. We're up to the challenge. Another group that was up to the challenge were the first humans to fly. No, not the Wright brothers, more about them later. But before the first airplane, men and women took flight using balloons. Here's flight school student reporter Nicole Boyd, and she's looking for a balloon ride.
Well, it is a great day for a balloon ride. But first, let's do some homework. Let's talk to Smithsonian curator Tom Crouch about the history of the balloon.
The question of why balloons were invented, when they were invented, is really interesting, because balloon technology and science are so simple that, in fact, ancient peoples who were capable of weaving tightly woven fabric ought to have been able to build a balloon. But in fact, it doesn't happen until 1783. And I think it happens then because the scientific revolution is going on. People, scientists, are uncovering the constituent gases of the atmosphere. And when they find hydrogen, the lightest of all the elements, and they stop and say, you know, if we could fill a bag with this stuff, it would fly. 1783 really was the year of the balloon. The Annus Mirabilis, the French called it, the miraculous year. It began on June 4th of that year when the Montgolfier brothers flew the first little hot air balloon, no people on board, from Annonay, France. In August of 1783, another fellow, Jacques Charles, flew the world's first hydrogen balloon, again, small, no people on board, from Paris. In fact, from the spot where the Eiffel Tower stands now. And then in September, the Montgolfiers flew the first living creatures, a sheep, a duck, and a rooster, from the palace at Versailles, the Louis and Marie Antoinette watching and all that. On November 21st, the Montgolfiers flew the first human beings from Paris, and less than a month later, Jacques Charles and a friend made the first human flight aboard a gas balloon, a hydrogen balloon. So it was an incredible year, and all during the year, the crowds that showed up for these events kept growing, so that by that gas balloon flight on December 1st, 1783, it's estimated that half the city of Paris showed up. There was just this overwhelming craziness about balloons, this desire to see them, the people finding it difficult to believe that human beings were actually leaving the ground.
It was the beginning of what some call balloonomania, an era of excitement that swept across Europe as the first human beings took to the air. Here at the Udvar-Hazy Center, you can see items that date back to the first balloon flights. Everyday items that celebrate these great achievements. Balloon-themed plates, vases, paperweights, tiles, clocks, ceramics, knickknacks, even balloon-themed furniture. These walnut chairs from the 1700s include balloon-themed embroidery and backs, featuring symbols that reflect a successful flight or a disastrous flight. Father Time's hourglass and the Grim Reaper's scythe.
You got all that? Because there is going to be a quiz. Well, now let's find someone to take me up in a balloon.
Hi, I'm Keith Sproul. Let's go for a balloon ride.
That's balloon pilot Keith Sproul, and he's giving me the complete rundown of how we'll get the balloon inflated and then up and flying. You start with the balloon laid out on the ground and the basket that you ride in, on its side. A big fan begins the inflation process, blowing the air into the balloon. It takes a lot of hands to keep the balloon under control and in the best position to catch the incoming air. The process always draws a crowd. Once the balloon is nearly inflated, it's time to fire the propane-fueled burner. And that finishes the job. Climb into the basket, and it's up, up, and away.
What are some of the requirements to actually be a balloon pilot?
It's a pilot's license just like fixed wing. You have the legal requirements from the FAA is 10 hours of flight, 6 hours with an instructor. You have to pass a fairly significant written exam and also then a flight check. Even though the FAA requires 10 hours, that's not really practical. 15 or 20 is a little bit more practical.
Now, how does being a pilot for a hot air balloon differentiate from being an airplane pilot?
In some aspects, it's a lot easier because we don't have near the instrumentation or the complexity of stuff, but we have to pay a lot more close attention to weather.
So it's more gauging.
Yeah, weather that's 10, 15 miles an hour wind for fixed wing pilots, yeah, so what? Or a thunderstorm that's 40 miles away, well, they might just have to fly to a different airport. Well, 50 mile away thunderstorms, I won't fly if it's any closer than 50 miles. We only have a variometer, how fast you're going up and down, an altimeter, and a temperature gauge of how hot the top of the balloon is. And then we have fuel gauges on the tanks.
What are some of your favorite places to fly in the hot air balloon?
Canyons, gaps, and gorges. Letchworth State Park in upstate New York, which is called the Grand Canyon of the East. Delaware Water Gap in New Jersey. Paladero Canyon in Amarillo, Texas. Meteor Crater in Arizona, which I was the second person ever to fly into that last February.
Wow.
I flew over in Switzerland last year. It's a lot of fun. Next March, I got invited to take my birthday cake balloon. I've got a balloon that's physically the shape of a birthday cake. It's got 20 candles on top of it, and I fly it at like the 10th anniversary of an event or something. Balloon events have their celebration, and they invite me to come fly it there.
So, in a word or two, how do you sum up working in a hot air balloon?
It's just awesome.
Good word for it. Thank you again, Keith, so much for the ride.
Oh, you're welcome. It's a lot of fun.
As you can see, you can learn a lot. From above!
Well, let's see what you've learned. Time for the first couple questions from our flight school quiz. Question number 1. According to the National Air and Space Museum Senior Curator of Aeronautics, Tom Crouch, what year was the year of the balloon? Was it A, 1776, B, 1783, C, 1812, or D, 1961? Okay, let's go on to our next question. What were the first living creatures to fly in a balloon? Was it A, a man, a woman, a squirrel, B, a goose, a sheep, a pig, C, a sheep, a duck, a rooster, or D, the 3 blind mice?
All right, Mark, thanks a lot. You know, those questions just weren't so tough. So now we know a lucky few got to see what it looked like from above using balloons. But what about the rest of us? We want to see that view. Enter the airplane. Flight school student reporter Gloria Powell begins our conversation about the view from the first airplanes like the one behind me and the men who brought us that view, the Wright brothers.
Any conversation about the Wright brothers should include the Wright Experience in Warrenton, Virginia.
The mission of the Wright Experience is to discover the secrets of the Wright brothers to inspire a new generation. It's basically an educational research project by reverse engineering the aircraft and components and testing them and trying to learn how the Wright brothers were capable of discovering flight in 4 years. What we do here is we actually build the aircraft that the Wright brothers built. We put them in the wind tunnel, we test them, we let the students and engineers analyze them and write papers about what the Wright brothers did.
Not only did the folks at the Wright Experience build the same planes the Wright brothers built, but they built them the same way the Wright brothers built them, by hand, using the same materials and same techniques. Each and every part of the airplane is built right here.
At the Wright Experience, we find that if we do not build the parts here, we do not have the authenticity that we need for the testing of this project. We know so much about aviation today that we have a tendency to modify things, and we don't want to modify a thing. This has to be exactly the way the Wright brothers built it. To do that, we do it right here in the shop, in the house. The reason for that is if we test it and we change something, then we do not have data of what was really Wright brothers airplane, and that's what we're trying to find out. That tells us what they were thinking. We're trying to get into their heads.
And keep in mind that the Wright brothers designed and built airplanes before there were calculators and computers, a fact the Wright Experience is eager to show students.
We want to be in every classroom in this country to show them that math is fun, and math built this airplane with the Wright brothers, 2 bicycle mechanics. They used simple math to design and build this airplane. Math has a practical application. They turned out to be our first aeronautical engineers. They were not just lucky bicycle mechanics.
As the Wright brothers worked to transform the Wright Flyer's public image from flying contraption to airplane, early movie cameras were there. This footage is from Orville's first public flight in the United States, September 1908. It was a proving flight for the U.S. Army officials at Fort Myer, Virginia, just outside Washington, D.C. Before the Army would buy any Wright Flyers, Orville had to prove that the airplane could carry 2 people sitting upright, travel at least 40 miles per hour, and stay aloft for at least 2 hours. Movies were silent back then, no sound, but we think we know how Orville would have answered a few questions before his flight.
Excuse me, Mr. Wright, what's the goal of your flight today?
Our goal for today on September 6, 1908 is to have a successful flight here at Fort Myer in order to secure a U.S. Army contract and a U.S. government funding for further building of the Wright Flyers in Dayton, Ohio, to lead America into the aviation future of the 20th century.
And are you nervous at all about today's flight?
Well, a little bit nervous, yes, because the weather contingencies are always a concern. If there's too much windage, we can't fly. If there's any threat of rain, we can't fly. Also, funding is very critically important because Wilbur and I have built this aircraft and test flown it on our own money from our bicycle shop in Dayton, Ohio. And now we're at the point where we have no more funds, and so we need to secure this one-page government contract for $25,000 in order to go forth with new models of the Wright Flyer. Because every time we fly, we learn something new and we go back and rework the air machine accordingly.
Before you go, Mr. Wright, could you tell us about the view from up there? What's it like to be up there with the birds?
Well, when you are flying, you are concentrating so hard on working the various controls of the airship that the only times you get to enjoy the view are those momentary times when you feel like an eagle soaring from on high. And all the times that you've watched eagles soaring as you've been growing up and wondering what it was like, when you're actually up in an airplane, you actually feel like an eagle and you see the view you've always wanted to see.
It wasn't long before everyone could see what the Wright brothers saw as movie cameras went along for the ride. And it was a 1908 Flyer, the same model recently built at the Wright Experience, that brought back the first successful aerial motion pictures. And here's what remains of that footage. Shot while Wilbur Wright demonstrated the Wright Flyer for Italian government officials outside Rome, Italy in 1909. But black and white silent film doesn't quite tell the whole story.
So what was it like to actually fly in this airplane? What did you see? What did you hear? Well, imagine you're my passenger. We're sitting next to each other on this airplane. We're behind these wires. We're about to take off. We're sitting on a wooden rail that's stretching out in front of us like half a railroad track. Right next to you is the engine. And the engine is so loud that I would be yelling in your ear just like this. Behind us, the propellers are turning at a furious speed. We can hear the chains moving through the chain guides. The airplane is straining to take off because it's connected to a catapult that has 1,500 pounds of weight that are going to drop and shoot us into the air, but we're not going anywhere. Why? Well, there's one thing that's holding us back. It's a wire that's looped around this little metal finger right here. The wire is attached to the rail, and it's the only thing that's keeping us back. And as soon as we pull this trigger, the wire is released, and we shoot down the track, and we're in the air in about 3 seconds. And that's exactly what you would feel. And we'd suddenly shoot backwards like this. I would pull the control lever back to get the airplane, the nose up. Airplane would take off. I'd push it forward again. We'd be climbing very rapidly. And then as soon as I wanted to go higher, I could pull it up. If I wanted to go lower, I would push it forward. If I wanted to turn to the left, I would push these sticks forward, or to the right, I'd come back. And we would be up in the air. Now, if you were Wilbur's passenger outside Rome in 1909, you'd also be holding a motion picture camera, and you'd be taking the very first films that were ever shot from an airplane, and you'd know exactly what it felt like.
In 1912, a movie camera was strapped to the airplane before it took off from New York Harbor. That's ice in the water. Sure looks cold. Once in the air, the camera saw what the pilot saw. The Statue of Liberty, Ellis Island, the Brooklyn and Manhattan bridges. And back safely with the perfect water landing. That water still looks awful cold, and those men are standing in it. Brr! Motion pictures from an airplane gave the world a bird's eye view. A view that wasn't determined by which way the wind blew, like when you're flying a hot air balloon, but a view from above determined by what the pilot wanted to see.
I can see all sorts of cool stuff up here, but what I'm really interested in is to see how well you're listening. Time for a couple more quiz questions. Question number 3. How fast did the 1908 Wright Flyer have to travel through the air to meet U.S. Army requirements? Was it A, faster than a flock of geese, B, 20 miles per hour, C, faster than an automobile traveling on the ground, or D, 40 miles per hour? Question number 4. What year were the first successful motion pictures taken from an airplane? Was it A, 1783, B, 1812, C, 1855, or D, 1909?
Do you see how our view from above is evolving? Balloons got us up there, and planes let us see what we want to see. But what if we could combine the floating of a balloon with the mobility of an airplane? Well, flight school student reporter Kevin Shanahan can answer that question with 2 words: womp, womp.
You know, like the sound a helicopter makes, womp, 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 womp. But we'll get back to that in a moment. When it comes to helicopters, whether it's a big one, a small one, a sleek one, or a funny-looking one like this one from the 1950s, nicknamed the Flying Banana, people always ask the same question: how's that thing fly? The blades act as small wings, and they spin so fast that they create one continuous disk of lift. And when those blades collectively change angle or pitch, controlled by the pilot's left hand, the aircraft rises or descends. The pilot's right hand points the control that tilts the whirling disc above. Point right, go right. Point left, go left. The tail rotor is at the back of the helicopter, and altering the angle of these blades via the foot pedals also affects direction. Push one pedal and the aircraft spins in one direction. Push the other pedal, spin in the other direction. As you can see, it takes hands and feet working separately, yet at the same time, to pilot the aircraft. It's a skill that takes time and practice to master, but once it's mastered, the pilot can take full advantage of the helicopter's unique abilities.
The great advantage of a helicopter is that it can hover motionless in the air. It can also take off and land nearly vertically. This allows you to operate in certain environments that airplanes cannot operate in. But it also allows you to monitor things on the ground that you could not do from an airplane, because an airplane would have to continually remain in motion over a site. That makes it very difficult for a pilot or an observer to maintain contact with the things that they're trying to observe on the ground.
Combine the flight abilities of a helicopter with the skills of an experienced pilot, add high-tech television cameras, and you get a view from above that's like no other. The view from a television news helicopter. Once in the air, a TV news helicopter becomes a mini TV studio in the sky, with cameras and monitors controlled by an expert operator who sits in the back seat.
Well, first of all, the camera is actually on the nose of the helicopter, the main camera. This is the laptop unit that I use to control it. As you can see, spin it around. I can move it in 360 degrees to get almost any angle I want, depending on the position of the helicopter.
The pictures captured by the two onboard cameras are sent back to the TV station via a transmitter attached to the bottom of the helicopter. 4 monitors allow the operator to see what the cameras are seeing, what's being sent back to the station, and what's currently on the air, what we see at home. Thanks to the TV news helicopter, new perspectives are delivered to our living rooms daily. It's like having a front row seat to the events that shape and affect our day-to-day lives. Firefighters in action. An 18-wheeler on its side. Traffic slows for a look. Idle gas tankers, the result of us driving less. Buildings below bathe in the setting sun. Police activity backs up the evening rush hour. While the camera operator is focusing on the events on the ground, the pilot is putting mathematics to work.
On a daily basis, most of the math I use is related to the weight and balance of the aircraft and adding up how much it weighs empty, how much weight the fuel is, myself, and whether I'm going to remain within the accepted envelope of performance for the aircraft's limitations, because the weight obviously will change when I burn fuel, so I want to make sure it's always going to stay within acceptable limits. Other math I use is calculating time and distance. I know how fast I can go, I know how far I have to go, but how long is it going to take to get there?
You must admit, the view from a helicopter is very cool. But where can you see helicopters down here on the ground? I thought you'd never ask. The Udvar Hazy Center features several whirlybirds you can examine, as well as a vehicle like this one. Not a helicopter, but the technology from this vehicle made the modern helicopter possible. It's called an autogyro. The museum's autogyro was built in 1943 and was the last one built in the United States. It was used as an observation aircraft during the Second World War. It possessed advanced technologies of the day, like folding rotor blades, which made the vehicle easier to conceal when parked on the ground, a bubbled canopy which protected the pilot, observer, and a map table, and a clear bottom section below the pilot and observer. Talk about a window seat. Well, that's all the time we have for helicopters. Hey, wait a minute, I almost forgot. Hey, Roger, what makes that helicopter sound? You know, the womp womp.
The womp womp sound in a helicopter rotor is caused by the turbulence coming off the rotor tip blades and then the next rotor blade smacking into that turbulence. The bigger the rotor blade, the louder the womp. So if you have something like a Huey, which is the big old Army two-bladed helicopters, have a giant rotor blade on that, they really have a very loud sound. The more modern helicopters that have maybe 5 blades, when you hear those, you're going to hear a much finer sound. You don't get that womp womp. It's much more of a smooth purr to it.
Whether purring or womp womping, helicopters take us above our daily routine, far enough away to gain new perspectives, yet close enough to see the details.
And speaking of details, I'm close enough to some of these planes that I can see details I'd never been able to see from down below. Are you ready for one more question? I thought so. Question number 5. Which body part does a helicopter pilot use to control the aircraft? Is it A, right hand, B, left hand, C, both feet, or D, all of the above?
We're just over halfway with our quiz. I bet you're doing great. The views have been super so far, but what if we went even higher? All the way to the ceiling of our atmosphere, just short of space. Do you think an airplane could get us there? Flight school student reporter Kirsten Salpini has that answer.
The first airplanes took flight at the beginning of the 20th century, but it was only some 50 years later that an airplane reached for the Earth's ceiling. The Lockheed U-2, still in operation today, was developed by the U.S. military to be a high-altitude reconnaissance aircraft. Originally designed and built during the 1950s by renowned aeronautical engineer Kelly Johnson at the Lockheed Martin Skunk Works in California, the U-2 can take pictures of the Earth from an altitude of 70,000 feet. That's more than twice as high as an airliner flies today. At such extreme altitudes, the pilot must wear what looks like a spacesuit to survive the atmosphere at more than 13 miles up. The U-2 has long, glider-like wings that supply abundant lift at low speeds. The powerful single engine provides ample thrust to lift the lightweight aircraft into the stratosphere.
The view from up in the U-2, when we're cruising at altitude at over 70,000 feet, is just unbelievable to look at. You can see so much from such a large part of the country at any time, and just unobstructed, no clouds, no haze in your view, looking out at the horizon.
Even though this aircraft was designed for the military, it is also an instrument of science. The U-2 and its non-military counterpart, the ER-2, have supported the National Aeronautics and Space Administration's Airborne Science Program, which began in 1971. These NASA-operated high-altitude flyers have logged more than 4,500 data missions and test flights. The onboard instruments change the aircraft's appearance as instrument pods are added to the wings and the fuselage. Observation equipment inside the aircraft is also positioned within the nose and fuselage. The ER-2 gathers hours of information with cameras, sensors, and scanners, including a device that has vision like Superman.
And what it does is it uses radar energy versus light energy to take pictures. If you think of yourself in a dark room and you had a flashlight in your hand, how your eyes would see if when you turn on that flashlight, the flashlight gives off light energy, it hits objects, and the reflection of that light coming back to your eyes, the receiver, paints the picture for you in your head, in your eye. Well, this camera does the same thing, but it uses microwave or radar energy, where it sends the radar energy out, it hits the objects, it comes back in and is received, and computers put that image together just the same way your brain puts together what your eyes are seeing and gives you an image.
Which means it can see at night, as well as through clouds, smoke, and dust storms. Images from an ER-2 flight can produce a very colorful display, sometimes familiar, sometimes not. Though these colors look unnatural to our eyes, each color holds important information for NASA scientists.
Okay, a few more questions to go, I promise. What's the name of the non-military version of the U-2? Is it A, U-3, B, ER-2, C, You and Me, or D, SR-71? On to the next question. What's the normal operating altitude of the U-2? Is it A, 100,000 feet, B, 85,000 feet, C, 70,000 feet, or D, 55,000 feet? You know, I could stay up here all day just looking down, but do you think I could find a job where I can get paid for doing that? Nah, I didn't think so. But if you like airplanes and watching the weather like I do, I've got just the job for you.
Hi, I'm Captain Nathan Green, and this is the 316th Operations Support Squadron Weather Flight. In other words, the weather station at Andrews Air Force Base, Maryland. The mission of the weather flight at Andrews is to provide weather knowledge to crews that pass through Andrews to their destinations worldwide and to protect people and planes here at Andrews. I am privileged to work with a team of weather professionals.
Andrews Weather, Sergeant Whitney.
I knew I wanted to be a weather guy when I was in the 8th grade and my science class took a field trip to a National Weather Service weather station. And one of the technicians there was showing me the radar, and he was pointing out, much to my amazement, all the features on this radar, the rain showers, the thunderstorms, and some of the other features that were on there. And I got really excited, and I decided at that moment that that was what I wanted to do for the rest of my life. I come to work excited every single day. It's always something different. Weather is a puzzle that you can never solve. You can always try to outsmart it, but as we found out with all the weather events, Mother Nature always has the upper hand, and as soon as we think we've got it solved, it always teaches us a lesson.
Hey, have you ever wondered how satellites stay in orbit around the Earth? Well, it's as easy as spinning these keys. For this demonstration, the keys are the satellite and the lanyard is Earth's gravity. There's a constant tug of war between the Earth's gravity and the satellite's velocity. A satellite's got to reach orbital velocity, which is pretty fast. And if it doesn't get into orbit. If the satellite travels too fast and reaches escape velocity, it might spin off into space forever. Let's say everything's working as it should. This string represents the low Earth orbit, and this is where you find the International Space Station and the Space Shuttle. At the middle orbit, we find things like our GPS. And at the highest altitude, this is where you find our weather satellites. So the next time you see somebody doing this with their keys, you'll be able to put a whole new spin on it.
Now, that is cool. You know, and if I can do this, you can be able to do it too. Now that you know how satellites stay in orbit, let's see what weather satellites see. Flight School's Matt Fetters has more.
Polar Operational Environmental Satellites, or POES, like those represented here by the blue balls, orbit at 450 to 470 miles above the Earth and travel between the North and South Poles, or what's called a polar orbit. The POES satellites provide full coverage of the planet twice a day. Geostationary Operational Environmental Satellites, or GOES, provide the weather images you see on the nightly news as they track weather systems across the Western Hemisphere. GOES orbit the Earth at 22,500 miles above the equator, in geosynchronous orbit like the red balls here. They keep pace with the Earth's rotation and appear to be parked in space above the planet. Be it GOES or POES, they are operated by the National Oceanic and Atmospheric Administration, or NOAA, at the NOAA Satellite Operation Facility in Suitland, Maryland.
Our satellites are launched from either Vandenberg Air Force Base in California or the Kennedy Space Center in Florida. And then once they're declared operational and everything is functional on the satellite, it becomes owned and operated by NOAA.
The Satellite Operations Control Center is staffed 24 hours a day, 7 days a week, to make sure that the satellites operate at full efficiency. Satellite images can be spectacular and educational all at once. The ultimate view from above.
Information is received into this building from all of our satellites, is received into the control center here, and it's sent down to the 3rd floor, which is right below us where the computer center is at. The data is processed and turned into usable products for forecasters, and then it is distributed out to the user community, which consists primarily of the National Weather Service.
It's a short trip from the NOAA Satellite Operation Facility to the World Weather Building in nearby Camp Springs, Maryland, where weather professionals work to carry out the mission of the National Weather Service.
The mission of the Weather Service is to save life and property from any kind of weather event, whether it be flooding, hurricanes, snowstorms, ocean storms, lightning, thunderstorms, tornadoes. That's our focus. We do that mission by understanding the atmosphere, observing the atmosphere, and predicting what the atmosphere is going to do.
Satellites play an important role in that process, as does the ability to read or interpret satellite imagery.
Here in the Gulf of Mexico, that's a line of thunderstorms. And there are some actually thunderstorms here popping over Mississippi. You can see thunderstorms here up Minnesota, trailing all the way back into South Dakota. And then is a storm system, a larger weather system that's moving across just south of Hudson Bay here in Canada, moving from Ontario into Quebec.
To be effective forecasters, meteorologists take a global view of the weather. The weather that will affect your weekend plans is somewhere else in the world right now, heading your way. Case in point, September's Hurricane Ike.
Ike was a long story. Ike was a tropical wave that was first observed over Africa, exited the African coast, came across the Atlantic, and developed into a hurricane northeast of the Lesser Antilles. Strengthened there, went across north of Haiti, and made landfall in Cuba. All the time it's being observed by a variety of different systems, including satellite data. Ran along the spine of Cuba, made its way into the Gulf, and then finally made landfall in Texas. But the story doesn't end there. It kept moving northward and then northeastward rapidly, and its swath of wind damage extended all the way up into Canada.
Another hurricane that will not be forgotten anytime soon is 2005's Hurricane Katrina. Here is satellite imagery that lets us watch Katrina from the Atlantic Ocean across Florida, gain momentum in the warm waters of the Gulf of Mexico, slam into New Orleans, Louisiana, and then leave a trail of wind and heavy rains up through the Ohio River Valley all the way to the state of Maine. And it was from above, sadly, that the world was first able to view the devastation left behind. As we've learned, the view from above and the technology that brings it to us have evolved through the years, and nowhere demonstrates this better than the Looking at Earth gallery at the National Air and Space Museum in downtown Washington, D.C. Visitors see the distant past, the more recent, and the present of today. From this location, with our feet firmly planted on the ground, we can take flight and reach the heights our ancestors could only dream about, and learn firsthand that while the view may change, what remains is the beauty and usefulness of what we can learn from above.
Wow, I never knew you could learn so much from above. And for the last time today, let's see what you've learned. The final two questions of the flight school quiz. Question number 8. Which satellite sends us the weather images we see on TV? Is it A, GOES, B, Landsat, C, CloudSat, or D, Sputnik? Question number 9. What's the mission of the National Weather Service? Is it A, to close schools after a snowstorm, B, to protect life and property from any kind of weather event, C, to issue warnings about meteor showers, or D, to predict the weather on Mars? Well, want to know how you did? Well, you can find all the answers on the Flight School From Above website. There's the address. Good luck. From above at the Udvar Hazy Center, I'm Mark Lindesey.
All right, thank you, Mark. And while you're at the Flight School website, you can review the entire Flight School series. If you've been with us since the beginning, congratulations. Consider yourself a graduate of Flight School. For the Fairfax Network, I'm Kate Sullivan.